Hello everyone, I'm Disha from Sri Venkateshwara College of Engineering. In this video, we are going to learn about TCP Connection Establishment. The content covered in this video are Introduction to TCP, TCP Connection Establishment, TCP Termination, Facts on TCP, then few points on connection-oriented services and the operation to be followed during this connection-oriented services and why TCP is a connection-oriented service. Transmission Control Protocol is one of the important protocols in the Internet Protocol suite. It provides reliable, ordered, and error-checked delivery of bytes between the applications running on host communicating via an IP network. Major Internet applications such as World Wide Web, email, remote administration, and file transfer by rely on TCP, which is a part of transport layer of the TCP or IP suite. TCP is a connection-oriented protocol and the connection is established before the data is sent between the client and the server. So the server must be listening for the request from the client before the connection is established. So connection establishment is performed using the three-way handshake mechanism, and this mechanism will synchronize both the ends of the network by enabling both sides to agree upon the original sequence numbers. The mechanism also provides that both the sides are ready to and learn that other side is available for the communication. This is essential so that the packets are not shared or retransmitted during the session establishment or after the session has been terminated. The requesting end, that is host A, sends a synchronization segment determining the server's port number that the client needs to connect to and its initial sequence number. The server host B acknowledges its own synchronization segment, including the server's initial sequence number. The server also responds to the client synchronization by accepting the sender's synchronization number plus 1, that is x plus 1, and synchronization consumes one sequence number. The client should acknowledge its SYN number server by accepting the server sequence plus 1. This is known as connection is settled. Each side acknowledgement each other's sequence number by incrementing it. This is known as acknowledgement number, and the use of the sequence and the acknowledgement number allows both the sides to detect the missing segments or the segments which are out of order. Once a connection is established, acknowledgement typically follow for each segment. The connection will eventually end with RST, that is reset or tear down connection. The three messages that both the sides of the connection has to know are the ISNs to use for outgoing data, the buffer space available locally for the data in bytes, the maximum segment size in a TCP option, and sets the largest segment that the local host will accept. The MSS is usually the link MTU size minus the 40 bytes of TCP and IP address, but many implementations use segments of 512 or 536 bytes. Until now, we have seen the three-way handshake mechanism for the connection establishment. So the connection termination requires four-way handshake mechanism. So any device establishes a connection before proceeding with the termination. So three-way handshake was required to establish the connection between the client and the server before sending the data. Similarly, to terminate or stop the data transmission, it requires four-way handshake mechanism. The segments required for TCP termination are similar to the segments which was required to build up a TCP connection except the final request segment, that is FIN segment. The final request segment specifies a termination request sent by one device to the other one. The client is the data transmitter and the server is the data receiver in the termination process between the sender and the receiver. So the below diagram shows that the exchange of segments between the client and the server. The client sends the final request for the server, and the server receiving the final request will respond to the client by sending an acknowledgement, and or it also sends an final request, that is FIN, to the client, and the client would respond to the server by sending a last acknowledgement noting that the connection has been closed. Few facts on TCP. TCP is a connection-oriented protocol that enables two-way communication after the three-way handshake mechanism between the two endpoints, and TCP is reliable because the protocol ensures that all the data is fully transmitted and can be assembled in a proper order on the receiver side. And TCP allows data to be sent in an individual segments up to 1500 bytes in size, including the header. TCP is positioned at the transport layer in the OSI model, and TCP is usually in conjunction with the Internet Protocol and is commonly known as TCP or IP protocol stack. Connection-oriented services, the data streams or packets are transferred or delivered to the receiver in a similar order in which they have been transferred by the sender only. It is actually the data transfer method among two devices or computers in a different network that is designed and developed after the telephone system. Whenever a network implements its service, it sends a transfer of data or messages from the sender or source to the destination in a correct order or the manner. There is a sequence of operations that need to be followed by the users, that are establishing a connection, transferring data or messages, and releasing the connection. Establishing a connection involves a session connection to be established just before any data is transported or sent, with a direct physical connection among the sessions. Transferring data or messages means when a session connection is established, there we transfer or send a message or the data. Releasing the connection is after sending or transferring the data, we release the connection. Why the TCP is called as connection oriented protocol? The TCP is a protocol of the transport layer, which is known as the heart of the OSI model, and it is the connection oriented protocol, and two primary reasons are: the sender and the receiver stay connected until the transmission process is terminated or fully completed, and also ensures that the data reaches its destination. And if any data is lost, and then the receiver will ask the sender to resend the data. The order of the data sent by the sender is also same in the receiver side. That is, it is orderly placed in the receiver section. Thank you for watching this video. Please do like, share and subscribe.